Topic for the day is logarithms. Quite an important topic, and it has got heavy applications later on in physics, especially in chemistry also. In electrical engineering, you will have logs being used quite often. Okay, now logs, there are certain laws of logs which we will study, and we will see their direct applications. But logs were also in olden days used to make difficult calculations easy, like something like square root of 23.521 divided by cube root of 3.093 into something. Now these things are very complex to do manually. Now we have calculators, is fine, but ages ago logs and anti-logs were used to make these difficult calculations which were practically impossible manually. Okay, and these logs were of great help. However, that part is no longer in syllabus. It was removed many years ago. Now we have only the laws of logs and their application. Before you do this topic, you should have fairly good idea of indices. At least the various laws of indices and all you should be knowing, because they will be used in between here in logs. Okay. Now let us see what does this logs ultimately mean. The short form, we call it as logarithms, but now henceforth we will be addressing it as logs. Okay. Now 3 raised to 4 is what? 81. This you are fine with, right? 3 into 3 into 3, 4 times. So 3 raised to 4 is 81. Be careful. 3 raised to 4 is not 3 into 4. 3 raised to 4 is 3 into 3 into 3 into 3. 4 times. So that is 81. So now what do we do? We say that log of 81 to the base 3. You very well know this is the base and this is the index or the power. We normally write the base little bigger so that it can be differentiated from the power. So 3 raised to 4 is 81. This implies log of 81 to the base 3. This is the base. So log 81 to the base 3 will be your answer, that is 4. So finding the log of any number means finding out the index. So see, log of 81. So we write this as log 81 to the base 3, answer will be 4. So it is now cross check. 3 raised to 4, how much? 81. So we are correct. If we would have written this 5, suppose, then 3 raised to 5 will be how much? 243. Or यहाँ पे क्या है? 81. That means our answer is not correct. So did you get an idea? So finding the log of a number to a given base means we are simply trying to find the power or the index. So we say log 81. It is written like this, log with little space 81. So that to the base 3, this 3 has to be written little down. You can't write it here, it will become 381 then. So log 81 to the base 3 is 4. Okay. Now please understand, this log 81 is a single word. Okay, it is not log into 81. You can't multiply a word with some number. So log 81 is a single word, it's a single entity. It stands for log of 81. Instead of writing that, we just say log 81. Like in trigonometry, you might have come across sine theta, sine x. They are single entity. So same thing applies for log. So what I am trying to say now is, if you have something like log 81 upon 81, and if you cancel like this, meaningless, I mean it is senseless. You can't remove log from 81. Log 81 is a single word, single entity. So this is something absurd, you can't cancel 81 like this. But if you have something like log 81 divided by log 81, this is okay. Entire term will get cancelled and give you 1. It is like y upon y is 1. Two identical terms joined by division sign will give you 1. So log 81 upon log 81 will give you 1. This is fine. If you have something like 2 log of phi upon log of phi, 2 log of 5 upon log phi. Here log phi will get cancelled. You can't cancel phi and log, that is absurd. Log phi and log phi, the entire thing can get cancelled, because 2 log phi means it is 2 into log phi. So 2 is like a coefficient here. So then log phi and log phi you can cancel. It is similar to 2x upon x. This you can cancel, no problem. So similarly 2 log phi means 2 into log phi, the whole divided by log phi. So log phi as a single entity will get cancelled and the answer would be 2. This is correct. Okay. Now coming back to this, which what I had explained you, log 81 to the base 3 is 4, this you understood. This is called the exponent form. There are no logs here, and this is called the log form. Both are like equivalent, interchangeable. From exponential form you can go to log form, and from log form you can go to exponential form. Let us take one more example. Phi raised to 2, how much? 25. Phi raised to 2 is 25. So log of 25 to the base phi, log of 25 to the base 5. How much is the index here? 2. So this is called exponent form and this is called the equivalent logarithmic form. So log 25 to the base 5 is 2. Let's check. Phi raised to 2, not 5 into 2. Phi raised to 2. How much? 25. So we are correct. Okay with this. And now there are some restrictions on the base and also on these numbers. So that we will see first before we go to the laws of logs. Okay. See, suppose log of a to the base b, in general log of a to the base b, suppose the answer is c. And there are some restrictions. A cannot be negative. A cannot be negative. Okay. Second, this base b should be greater than 0. Okay, log of a negative number is not defined for us. So a cannot be negative. Then b has to be greater than 0. Again the base cannot be negative. B will have to be greater than 0 but not equal to 1. So it can be 0.5, that is fine. The base can be 0.2, chalega. Base can be 20, base can be 30, but it has to be greater than 0. Okay, that means it has to be positive, but it cannot be equal to 1. It can be equal to 1.5, 1.8, because if it is equal to 1, then you get some absurd results at times. So that is what it is defined. So a cannot be negative and your base b has to be greater than 0 but not equal to 1. Anything else is okay. So these conditions are fine. Now few other things. Log of let's take it as 1. A is not a problem, you know, because what is the restriction? A cannot be negative. Log of 1 to the base 10. Log of 1 to the base 10. How much will be this? Try and work it out now. This will be 0. because 10 raised to what? 10 raised to what will give you 1? That will be our answer. So 10 raised to what can give you 1? 10 raised to 0 can give you 1, because anything raised to 0 is 1. So log 1 to the base 10 is 0. Okay. Log 1 to the base 7. How much? Again 0. Because 7 raised to 0 is 1. So whenever you want to find the log of any number to the given base, we can do it orally if it is a simple number. We will ask ourselves 7, this is a base, 7 raised to what? Because finding the log of a number means finding the index. That's what I told you in the beginning. So 7 raised to what will give the answer 1? तो यह क्वेश्चन मार्क के जगह पे क्या आएगा? 0. So because 7 raised to 0 is 1. So log 1 to the base 7 is 0. Log 1 to the base 10 is 0. Have you realized something? In general, log 1 to any base is 0. Log 1 to any base is 0, of course with these restrictions. Okay, because if you take the base as 1, then it is very odd. Then you will have 1 raised to 1 as also 1, and 1 raised to 0 is also 1. So then it is very difficult. So therefore we don't take the base as 1. The conditions were specified. So remember these tips. Log 1 is always 0. Okay. To any appropriate base. Now let us see log 20, log of 20 to the base 20. Log 20 to the base 20. What will it be? How do we work out? We tell ourselves this 20 is a base. We do it in the mind or in the rough work column. 20 raised to what will give you 20? 20 raised to what? You remember that form in the beginning we taught you? Exponent form, log form. 3 raised to 4 is 81. So log 81 to the base 3 is 4. And then we can go reverse also. So 20 raised to what will give me 20? 1. 20 raised to 1 will be 20. So log 20 to the base 20 will be 1. Log 20 to the base 20 will be 1. Then log 8 to the base 8. Log 8 to the base 8. What it will be? 1. Because 8 raised to 1 is 8. So in general, log of any number to the same base is always 1. So log 40 to the base 40 is 1. Log 60 to the base 60 is 1, and so on. Comfortable with this? Okay. A quick one. Find log 16 to the base 0.5. That we saw before also. We were finding log of some numbers, but that was easy. Now here how to do? Log of 16 to the base 0.5. Now here judgment is little difficult, because we will have to write 0.5 raised to what? 0.5 raised to what will give you 16? Now this for most of you may be little difficult to judge, and sometimes even more complex numbers, difficult numbers will come, so then it is difficult. So we have a simple technique how to deal with such cases. We'll have to depend on indices for this. So what we do, we say let log 16 to the base 0.5. Log of 16 to the base 0.5, let it be x. let the answer be x, जो भी है. So log of 16 to the base 0.5, let it be x. Now 0.5 raised to x, 0.5 raised to x will be 16. Okay, this is converting log form into exponential form. You remember this? 3 raised to 4 is 81. So log 81 to the base 3 is 4. This is the base, this is the index. Answer is our index. So conversely, 3 raised to 4 is 81. So we have made use of that. 0.5 raised to x is 16. Now we depend on indices. You have learned how to solve these equations. 0.5 you take it as half. 5 by 10. So half raised to x is 16. So 16 will be 2 raised to 4. Now we will have to equal the bases. So this half can be written as 2 upon 1. But then when we reciprocal the base, you remember the laws of indices. When the base is reciprocaled, the power will change the sign. So if it is positive, it will become negative and vice versa. But we have to simply take the reciprocal of the base. What is reciprocal? Interchange of numerator and denominator. So now this would be 2 raised to minus x. 2 raised to minus x is 2 raised to 4. So bases are same. So power also will be the same. Bases are same. So power also will be the same. So minus x will be 4. But our target is to find x. So x would be minus 4. Therefore, log of 16 to the base 0.5 results in minus 4. Now do not confuse this. I had told you that the log of a negative number we do not consider, at least at the school level. But log of a number can be negative. See the difference. You can't have log of minus 16 but at the school level, but log of 16 to a proper base, the answer can be negative. It can result in a negative answer. So this is fine with you? Let us now come to the laws of logs. First, log A plus log B is equaling log of AB. Use power of observation here, you will understand better. Now here I have not written the base. See, base is not written here, base is not written here. So it is to be taken as 10. Okay, in school, so at school level the base will be taken as 10 if the base is not given to you. And laws of logs will work provided the bases are same throughout. Suppose here if you take the base 7 and here if you take the base 10, no, then the laws of law, this law will not work. So the bases have to be the same. यहाँ पे अगर base 10 है तो यहाँ भी base 10 होना चाहिए. And answer also will come in base 10. If it is base 3, no problem. So log A to the base 3 plus log B to the base 3 will be log of AB to the base 3. Okay. But here the bases are not written, so they are presumed and understood to be 10. That's the convention. Example, log of 7 plus log of 5. These are the laws of logs which are very important and they are is the heart of the topic. Log of 7 plus log of 5 will be how much? Observe this and you can get it. Log 7 plus log 5 will be log of 7 into 5. That is log of 35. Got it? Now second. So it is log A plus log B is log of AB. Now log A minus log B. Log A minus log B. This will be log of A by B. Mind you, it is not log A upon log B. This is the most common mistake. I mean, first time when you are doing, most of you will make this mistake. Okay, but you see how you can minimize this. Observe this actually, use power of observation. Log A minus log B will be log of A by B. Example, log 8 minus log 2. Log 8 minus log 2 will be log of 8 by 2. Fair enough. Log A minus log B is log of A by B. So, log 8 minus log 2 will be log of 8 by 2 and not log 8 upon log 2. No, this is wrong. It will be log of 8 by 2. Now, this can be simplified here because it is 8 divided by 2. So, this will be log of 4. Ultimately, final answer. But log 8 upon log 2 you can't cancel. First of all, log 8 minus log 2 is not equal to log 8 upon log 2. Okay, that is wrong in the very first place. But suppose if we consider this as some other expression and you are inquisitive to know log 8 upon log 2 kya hoga. We will see that later on, but 8 upon 2 cannot be cancelled. Because remember what I told you in the beginning, log 8 is a single number, single entity. You can't separate log and 8. Log 8 is single. It is like, say, Manish, name of a person, divided by MAN. What, you will cancel this? No, no. It is meaningless, isn't it? Because Manish is a single word. It is not M into A into N into I into S into H. It is not like that. Manish is a single entity. So you can't cancel like this. It will remain like that only. So something similar applies to log. Log 8 is a single entity. Log 2 is a single entity. You can't cancel 8 into simply because log 8 is not log into 8. If it was log into 8, something like that, okay, then you could have cancelled. But here the situation is different. This is log of 8 by 2. It's a pure number, 8 by 2. So 8 upon 2 is 4. So it is log of 4. So there is a big difference between this and this. Here you can't cancel. Here we can very much cancel. So this completes with your second law. Third one is like this. Log A raised to B. It is log of, you can put this in bracket also if you want. Log of A raised to B will be B log A. Log of A raised to B will be B log A. The power becomes the coefficient. Log of A raised to B is same as B into log A. Now here two entities are there, like one is log A, single gatha, other is B, and बीच में क्या sign है? Multiplication, B log A, B into log A. Example, log of 7 raised to 3. Log of 7 raised to 3. तो किसका log हम find कर रहे हैं? 7 raised to 3 का log हम find कर रहे हैं. This will become 3 log 7. 3 log 7 means 3 into log 7. Okay. Now, however, caution, log 7 the whole raised to 3 is not equal to log 7 the whole raised to 3 is not equal to 3 log 7. This is log of a raised to b. It is not log a the whole raised to b. So see where the law can be applied and where it cannot be applied. So log 7 the whole raised to 3 is not equal to 3 log 7. Then what will it be? It will be log 7 into log 7 into log 7. That's it. It is like 5 cube is 5 into 5 into 5. So log 7 the whole cube will be log 7 into log 7 into log 7. Done. But it under no circumstances will it be 3 log 7. 3 into log 7 nahi hoga. Okay. So there is a difference between this and this. This is log of 7 cube, whereas this is log 7 the whole cube. Here we are finding log of 7 and then cubing it, whereas here we are cubing first and then finding the log of it. So you can visualize the difference between the two of them, significant difference. Fine, now we are done with your laws of logs and we will soon see some typical problems. Question 1, prove that 2 log of 15 by 18. So it is like 2 into log of 15 by 18 minus log of 25 by 162 plus log of 4 by 9 equaling log 2. We have to prove this. So here, now since it is proved that, we will have to go by LHS and RHS approach. Now LHS will be this 2 log of 15 by 18 minus log of 25 by 162 plus log of 4 by 9. Now first of all, before we apply laws of logs, as you can see we can apply many laws of logs here. You will have to take any coefficient in the power, otherwise it will be a problem. See, if you remember the laws of logs, log a plus log b is log of ab. So what was the coefficient for log a? What was the coefficient for log a? 1 log a, which we never write like 1 log a, we just write log a. So we'll have to first take care of the coefficients. So this will be log of 15 by 18 square. The coefficient has been taken in the power minus log of 25 by 162 plus log of 4 by 9. Now you apply laws of logs together, it will be easier. Now this will be, this is like log a minus log b plus log c. Don't get confused in board mass and all, because if you try to apply log a plus log b, it will go wrong, because this is not log a plus log b. There is minus sign here, so you will get confused. So now that coefficient has been taken in the power, we just run across and apply the laws together. Okay, so this is like log a minus log b plus log c. So minus we take it as division, like log a minus log b will be what? Log of a by b, and log b plus log c will be log of b into c, log of bc. So this will be log of 15 by 18 into 15 by 18 divided by this. So when I am dividing, then it will become reciprocal, multiplication ho jayega, into 162 upon 25. See, log a minus log b. This will be what? Log of a by b. So this is log of a divided by b. So divided by 25 upon 162. So it will become into 162 upon 25 plus log of 4 by 9. So that will become what now? Into 4 by 9. So plus will become into log a plus log b is log of ab, and log a minus log b is log of a by b, not log a upon log b, log of a by b. Now we will need to simplify this. So 6 plus 2, 8, 9, this will go by 9, 9 ones are 9, 18, this will get cancelled. Okay, anything else? Yeah, 5 3s are 5 5s are, then again 5 3s are. Now 3 into 3, 9, and that will get divided 18. So 3 into 3, 9, 2, and this 2 and 4 now. Okay, anything else? No, only this remains. So this is equaling log of 2, correct? This is equaling log of 2, equaling RHS. That is what we wanted. Log of 2 equaling RHS. Hence proved. So we have easily proved that the given expression reduces to log 2 after appropriate simplification. This is a very typical and standard sum. This completes with your question 1. Question 2. If log of x plus 5 plus log of x minus 5 equaling 4 log 2 plus 2 log 3, find x. Okay, these are simple logarithmic equations. So how do we tackle them? See, here nothing has to be proved, okay. Certain things are given equal and you have to find out x. How you have normal equations? These are logarithmic equations. So if log of x plus 5 plus log of x minus 5 is 4 log 2 plus 2 log 3, find x. Okay, let's see how do we go about it. Now see, here there is no problem. Log of x plus 5 plus log of x minus 5. This plus this, so coefficient is 1 here, so no problem. Here also coefficient is 1, and instead of having log of x, you are having log of x plus 5. Okay, this is equaling 4 log 2, so this will create a problem because you won't be able to apply laws of logs unless the coefficients are 1. So take care of the coefficient, you push it to the power. Which law? Log number, that law number 3, log of a raised to b is b log a. Okay, you need not write the names of the logs in the exam, you have to just apply it. So this will be log of 2 raised to 4 plus log of 3 square. Now this is log a plus log b, that is log of ab. Log a plus log b is log of ab. So this will be what now? Log of ab. Remember the very first law, log a plus log b is log of ab. So log of x plus 5 plus log of x minus 5 will be log of x plus 5 into x minus 5, equaling log of 16, 2 raised to 4, and 3 square log of 9. Now this will be log of x square minus 25 is equaling log of, now log a plus log b is how much? Log of ab. So this will be log of 16 into 9. So far comfortable? I'll take it here now. Now log of x square minus 25 is equaling log of 144. 16 into 9, okay. Now see, we have log of this is equaling log of that. So this will equal that. Na? if log of x is equaling log of y, then naturally x will be equal to y. Or here we can write, if you want, taking anti-log on both the sides. So anti-log is something which nullifies the effect of a log, but then that can be used only if you have something like log a is equaling log b. If it is of this type, log of this is equaling log of that, then we can say a is equaling b. But if it is something like log a plus log b is equaling, suppose, log c, then you cannot take anti-log like this. You cannot say, oh, therefore a plus b will be c, nullifying the effect of a log. It doesn't work like that. So the reasoning what we are using is, if log of a is equaling log of b, then a will equal b. So on this reasoning, so this will imply x square minus 25 is equaling 144. X square minus 25, log of this is equaling log of that, so this will equal that, like that. So this will be x square is equaling 169, x will be square root of 169, which is plus or minus 13. Okay, this is done. But then here you have to be careful. Huh? Minus 13 we won't be able to consider, because if I put it in the original equation, always put it in the, to verify your answer, don't put it somewhere in between, put it in the original equation. Original equation, if you put it x as minus 13, you will get minus 13 plus 5, that is minus 8. So it becomes log of minus 8. And we told you in the beginning, log of a negative number cannot exist at the school level. Okay. Log of a number, log of a positive number can be negative. The answer can be negative, but you can't have log of a negative number. So here we will have to write discard x equaling 13, x equaling minus 13. So final answer is x equaling 13. And we are done with this question. So this completes with your problem 2. Question 3. If log 25 to the base x minus log 5 to the base x equaling 2 minus log of 1 upon 125 to the base x, if this is there, find x. Again a logarithmic equation. Now there in the previous one the base was 10 throughout, so no problem. Here the base is x throughout. So what to do, what you do is, see, there are two ways of approach now. Both are equally good, but in some cases the first one is better, the previous approach was better. Okay, we kept certain logs here and certain logs there, and we came to a conclusion, log of this is equaling log of that. Okay, here the problem is, see, log, 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 and here there is a number. Now this number will create a problem. So some of you may feel that let's write 2 as log 100. Okay, because log 100 is 2, isn't it? See, log 100, no base is given, matlab the base is 10. I am writing it. So log 100 to the base 10 will be 2, because 10 raised to 2 is 100. So as the base changes, answer will go on changing. So I can, okay, now see, log 100 to the base 100 will be how much? I am taking the log of the same number. We are just changing the base. So naturally answer will change. No? Log 100 to the base 100 will be 1, because 100 raised to 1, not into 1. 100 raised to 1 will give me back this 100. Similarly, log 100 to the base 10 is 2. So 10 raised to 2 gives us 100, and that is correct also. But if you write 2 as log 100 to the base 10, it is not good. I told you laws of logs will apply if the base is same throughout. Here the base is x, here the base is x, here also base is x. then how can I write 2 as log 100 to the base 10? Because then what is happening is the base is not in agreement or in harmony with the other common base. So what we do, we keep all logs on one side and keep this single number on the other side, no problem. So we will write like this: log 25 to the base x minus log 5 to the base x plus, here we will transpose, this will be log of 1 upon 125 to the base x is equaling 2. Let this be 2 like this only. Now see, everywhere bases are the same. Do you find any coefficient here? 1. Coefficient 1. Coefficient 1. So no problem. We can just run and apply laws of logs the way we did in the, I think, the very first question, prove that question. Now here this will be log of 25 log a minus log b, that is log of a by b. So this will be this, and plus log of 1 upon 125. So plus will get converted into multiplication into 1 upon 125 to the base x. That's important. If you do not write the base, it will be taken as 10 and things go haywire then. Here the base is x throughout, equaling 2. Okay. So log of, this is like log a minus log b plus log c. We are applying it continuously together. Now this will be log of 25 ones, 25 5s are log of 1 upon 125 to the base x is 2. Now we have come to the best simplified form. So how do we go about it? Base raised to index gives the answer. Like that was the exponential form, convert into log. Now log we convert into exponential. In case you are not able to correlate, I would like to draw your attention to this fact. In the beginning we told you 3 raised to 4 is 81. Okay. Which automatically implies log of 81 to the base 3 is 4. Right. So 3 raised to 4 is 81. So that fundamental we will use here. Therefore, I have taken these two sums back to back. Okay. Like the previous equation what we took, there we kept all logs on one side and the other log on this side, and we could easily get it. Here this number was coming, a lone number, which was creating a problem. So then it is better to tackle this way. So this will be x raised to 2. X raised to 2 is 1 upon 25. So x will be square root of 1 upon 25. So this will be plus or minus 1 upon 5, right? Square root of 1 upon 25, square root will have two values, but we will have to discard. We will have to discard x equaling minus 1 upon 5, because here x stands for your base, and we told you base has to be greater than 0. It can't be negative. So this we will have to discard, and our final answer would be x is equaling 1 upon 5, and this is our answer. So comfortable with this? So this completes with your question 3. Question 4, log 225 upon log 15 equaling log x. Find x. Okay, comfortable? Log of 225 upon log of 15 is equaling log of x. Find x. Understand the difference between question 4 and question 3. There we applied log a minus log b, that is log of a by b. But here we can't apply that law. We cannot write this as log of 225 minus log of 15. This is not possible. Recollect the caution tip what we had given you. See, log A minus log B will be log of A by B. So this will be log of, if this is my expression, this will be log of 225 upon 15. This is correct. So log A, now if it is like this, log A minus log B, this will be log of A by B. But we have something different only here. We have log A the whole divided by log B. Look at this. Are these two expressions same? No, they are totally different. You can't cancel log, or you can't cancel 225 upon 15, or some of you may be feeling that, oh, chalo, we will take log common. I told you in the beginning, log 225, log 81, these are all single entities. You remember I gave you an example, Manish upon MAN. We cannot cancel like that because they are not joined by multiplication sign. So division is not possible for them. So this is log of 225 divided by log of 15. If it is like this, log of 225 upon 15, here we can cancel. This is a pure number. But this is log 225. It's a single entity. And this is divided by log of 15. So neither we can cancel log, nor can we cancel 225 upon 15. Okay, and nor can we apply the law log A minus log B is log of A by B, because this is log A by log B. It is not log of A by B. So you compare the two sums side by side and understand. Understand the difference again. Understand the difference between log of A by B and log A by log B. Both these terms are not the same. They are way different from each other. Log of A by B will be log A minus log B. This is fine. But this will not equal, log A by log B will not equal log A minus log B. No, this is not correct. So now how do we tackle this? So we apply our third law. Okay, this will be log of 15 square is not log 15 the whole square, mind you. It is log of 15 square because this 225, I am just writing it in a different format, 15 square upon log 15 is equaling log x. ये तो पहले से equal था. Now power will become the coefficient. Law number 3. Log of a raised to b, log a raised to b will be b log a. Power becomes the coefficient. So now here the power is meant only for this 15. It is not for full log 15. Okay. So this will become 2 log 15 upon log 15 is equaling log x. See, bases are not given, so they are understood to be 10. Here we can cancel log 15 and log 15 because the whole term is getting cancelled. Log 15, and this 2 is attached to log 15. This 2 is attached to log 15 by multiplication sign. So there is no problem. So this now 2 idhar akela reh jayega. 2 into 1, that is 2. Okay. So now you will have 2 is equaling log x. This is clear. Or we can also write log x equaling 2. What is our target? To find x. So this base is what? Base is not given here. So base is actually 10. Now same, convert log form into exponential form. 10 raised to 2 is equaling x. 10 raised to 2, not 10 into 2. X is 100. and this completes your sum. So be very careful what situation are you getting in the exam. So question 4 now stands complete. Question 5. Given log x equaling m plus n, log y equaling m minus n. Okay, so log x is given to you, x is not given to you. Log x value is given and log y is given to you. Express the value of log of 10x upon y square in terms of m and n. Okay, now start with this log of 10x upon y square. Use power of observation. This will be log of a by b, law number 3. Log of a by b. You recollect something? Log a minus log b. We'll write here for the benefit of all. Log a minus log b is log of a upon b. This you are aware, right? So reverse is also true. Log of a by b will be log a minus log b. That is what is being used here. Now this is log of a by b. So this will be log a. So log of 10x minus log of y square. And this data we have to use somewhere, directly or indirectly. Here log x is given and log y is given. But I have log y square. Mind you, it is not log y the whole square. It is log of y square. So power becomes the coefficient. Remember law number 3, last time what I had taught. Okay, so that will be taken care. It will become 2 log y and log y value is given. But what about this log 10x? इसका क्या करने का? So allowed thinking, say 10x means 10 into x. So can't we write this as log 10 plus log x? Log 10, try this. Log 10 plus log x will be what? Log a plus log b is log of ab. We'll put it here. Log a plus log b will be log of ab. So reverse is also okay. Log of ab will be log a plus log b. So this is like your a and this is like your b. ये हो गया log ab. If I go reverse split, it will be log a plus log b. Getting the connection? This will become 2 log y. Done. Now you have to simply substitute. Log of 10 will be 1 because the base is 10. Here base is not mentioned, that means it is 10. So log of 10 to the base 10 is always 1 because log of any number to the same base is always 1. All these things we had discussed in the beginning. So log 10 will be 1 plus log x. Now what is log x? M plus n. So 1 plus m plus n minus twice of log y. Log y is given to us, m minus n. Now what remains is only simplify. So this is 1 plus m plus n minus 2m plus 2n. We'll see. So how much will be this now? So it will be 1. I am taking it up here, okay? M minus 2m will be minus m and n plus 2n will be 3n. So log of 10x upon y square will be finally 1 minus m plus 3n under the given condition. So this kind of questions can come in your exam very much. They are not too high level, they are like middle level questions and they are quite important. So this completes with your question 5. Question 6. Evaluate, or they can say simplify, log a the whole square minus log b the whole square. log a the whole square minus log b the whole square. So this will be 2 log a, isn't it? Sure. Mind you, we just discussed some time back. Log a square will be 2 log a. Like the law number 3, log a raised to b. Log a raised to b will be b log a. But log a the whole raised to b will not be b log a. Here log is of this. Here log is of a and then we are raising it to b. So this situation is like this. So this law will not work. Now what to do? Same problem comes here also in this term. Recollect your basic factorization of class 7, class 8. X square minus y square. X square minus y square. How can we write this, factorize? It will be x plus y into x minus y. So if you want to remember, then it's like this square minus that square. So it will be this plus that into this minus that. That will come to our rescue in such a situation. ये हो गया like your x, ये हो गया like your y. So x square minus y square. So that is x plus y into x minus y. So this will be x plus y into x minus y. Okay with this? So this will be, so log a the whole square minus log b the whole square will be nothing but log a plus log b into log a minus log b using our difference of two squares factorization funda. But we need to simplify to the best possible level. So log a plus log b will be log of ab. Log a plus log b will be log of ab, law number 1, into log a minus log b will be what? Log of a by b. So this bracket, if we don't put also, it is okay. Or then we'll have to change this like this. So log a minus log b will be log of a by b, and log a plus log b will be log of ab, and both of them will have to be multiplied now because there is a multiplication sign in between. And yes, the sum is over. Nothing beyond this can be done. Question 6 is now complete. Question 7. If 2 log y minus log x minus 3 equal to 0, express x in terms of y. So we have to manipulate this now. So 2 log y minus log x minus 3 is given equal to 0. 2 log y minus log x minus 3 is 0, and we need to express x in terms of y. But right now log x is like single, so उसको कैसे न कैसे वहाँ से छुड़ाना पड़ेगा. Let's see how do we go about it. There is a pure number also involved, and there is one coefficient. So this coefficient, let's take it in the power, otherwise we won't be able to apply any laws of logs. So this we will take it as log y square. Mind you, not log y the whole square. By this time you will be okay with it. It will be log of y square minus log x is equaling 3. So 3 we take it on this side and we just keep the logs here. It's a pure number. Now there is some scope for applying laws of logs. Yes, here also we applied. Now also we can apply further. This will be like log a minus log b. Log a minus log b is 3. So that will be log of a by b. So this will be log of y square upon x is equaling 3. Now what to do? We need x in terms of y. तो log को तो ऐसे हटा तो नहीं सकते. Base is not given here. So what will be the base? 10. Now we can convert this log form into exponential form. 10 raised to 3 will be this. So it will be 10 raised to 3 will be y square upon x. What we want? See, now we have got rid of the logs. At the same time, it is both the things are equivalent. Express x in terms of y. So make x as the subject of the formula. So x you put it here. So x would be y square upon 10 cube. Now since this is small number, we will simplify. X will be y square upon 1000. And we have expressed x in terms of y. So what's the thing now? X is equaling y square upon 1000. Simple. So this completes with your question 7. Question 8. If log 27 equal to a and log 2 equal to b, find in terms of a and b the value of log 18, half log root 300, log of 7.5. Okay, so we want to find the values of log of this, half log this in terms of a and b, and the values are given. Okay, now see, log 2 is okay, it is in the simplest form, like, okay, 2 cannot be further decomposed. But this is log 27. We may not be able to use directly log 27 in any of the subparts. We may or we may not. So what we do is, we will try to find the simplest value. Like say, we will decompose this 27 into factors of 3 and we will try to find the value of log of some other thing which possibly could be used here. 2 is okay because it is already in the simplest form. 2 is okay, 3 is okay, 7 is okay. Okay, but here this 27 can be decomposed. So what we do, we will first tackle this and then come to this. Now log 27 is equaling a. This is given and no bases are mentioned, that means the base is 10. So that is also not an issue. This will be log 3 cube. Agreed? Log 3 cube, because 27 can be written as 3 cube. So this will be a. Now power becomes the coefficient. So 3 log 3 is equaling a. Log 3 is equaling a upon 3. This is fine. See, this 3 can't go here. The coefficient which is there, it is joined by multiplication sign. तो उसको छुड़ाने के टाइम पे division. So log 3 will be a upon 3. This is better. Now we have log 2 and we have log 3. Okay, so somewhere I will write this log 3 is a upon 3. No, we will be using this. No, this is not given, mind you, we have extracted it. And now I will be erasing the board, so I just made a note of. Now let us see first subpart, log of 18. Now you have to suitably factorize this in such a way that somewhere log 27 or log 2 or the recently found log 3, somewhere it can be used, because with this help only we are supposed to find that value. Now you can do like this. This you can write as log of 9 into 2. Nothing wrong. 9 into 2 is 18, so this becomes log 18. This is also log 18. We have just written it in a different form. Equal to, take this as your a and take this as your b. So this becomes log of ab. So that is log a plus log b. Right? This is a, this is b. So this is log of ab. So this will be log 9 plus log 2. Okay, log 9 plus log 2 is log 18. What is the law? Log A plus log B is log of AB. So we can think reverse. Log AB will be log A plus log B. We have used this reverse concept a couple of times in the previous sums if you just have a look. Now, do we have log 9 value anywhere? No, we have log 3. To decompose this now, this will be log 3 square plus log 2. This is okay. Log 2 is given as B. We can directly put it as B actually. Let's do it. Log 2 is known, now why carry the baggage? So this is B. This will be equal to sign. If you just write once, twice, it is sufficient. No need to write equal to in any step, in all the steps. Okay, once, twice, if you write for understanding, fine. This will be 2 log 3 plus B. Oh, this is nice. Log 3 we extracted in the beginning from log 27. So log 3 is A by 3. So this log 3 will be replaced with A by 3 plus B. So this is how much now? 2A by 3 plus B. Okay, we can take further LCM. So it will be 2A plus 3B, the whole divided by 3. This is the best form in which we can put it. So log of 18, the value is 2A plus 3B, the whole divided by 3 under the given conditions. Comfortable with these sums? Okay. Half log root of 300. Half log root of 300. So now what to do? Half, okay, will remain. This will be log 300 raised to half, because square root of 300, na? So it will be 300 raised to half. If it was cube root, then it will be 300 raised to 1 by 3. In general, nth root of x will be x raised to 1 by n. Okay. Now log, this becomes log a raised to b. So it will become b log a. So एक हाफ तो already बैठा है यहाँ पे. Power becomes the coefficient. तो ये multiply हो जाएगा उसके साथ. This will become log of 300. So this will be 1/4 log 300. Now this has come in a nice good form, but we'll have to tackle this. What we want the value in terms of a and b, na? So decompose 300. So it will be 1/4 log of, see, we can write this as 3 into 100. 3 into 100. So this becomes log of AB. So that will be what? Log A plus log B. So this will be log A plus log B. But this will come in brackets, because 1/4 is meant for this body, and this body corresponds to log 3 plus log 100. Like this is equivalent to this, multiply by 1 by 4. So if you do not put brackets, then 1/4 will get multiplied only with log 3. That will change the meaning and it will be incorrect. Okay, now log 3 we know, here it is. We had extracted in the beginning, a by 3 plus log of 100. One may wonder, where is log of 100? Nor can it be extracted also. Remember, log of 100 is 2 to the base 10. Log of 100 is 2 to the base 10. So remember these things. Log 1 is always 0. You take base, whichever base, see, even if you take the base as 7, 7 raised to 0 is 1. If you take the base as 8, 8 raised to 0 is also 1. So log of 1 to any base is always 0. Log of 10 is 1 to the base 10, of course, but we don't write that base 10 normally. Log 100 will be 2. How, if you would like to know, then here it is. Log 100 we want to find to the base 10. No base is given means base is 10. What is the answer? 10 raised to what? 10 raised to what will give you 100? 10 raised to 2 will give you 100. So log 100 to the base 10 is 2. So that data we have ready made. We don't have to depend upon the question for it. So log 100 is now 2. So ho gaya. This comes to this, this comes to this. Now of course you have to simplify this. This would be a plus 6 upon 3. Finally it is a plus 6 upon 12. Therefore, the value of half log root of 300 under the given conditions is a plus 6 the whole divided by 12. Now here b did not come in the picture, that's okay, because there were 3 subparts, no? So certain subparts came in terms of a and b, certain may come only in terms of a. Now the final one, subpart 3. Log of 7.5. So we won't deal with this decimal, we will simplify. This will be log of 75 upon 10, isn't it? 75 upon 10 is 7.5. So log of 7.5 is same as log of 75 upon 10. It is not log 75 the whole divided by 10. It is log of 75 upon 10 because यहाँ पे we can cancel. So 5 15s are 5 2s are. This comes to log of 15 upon 2. Now what to do? This is log of a by b. So that will be what? Log a minus log b. So log 15 minus log 2. Now what to do? Log 2. Log 2 is b, nice, but this log 15 is creating a problem. See, I have taken this very advanced subparts. In the exam, if such a heavy subpart comes, they will ask only one subpart, not so many. But I want you to get exposed to all tricky and good typical situations, so we have to take such subparts. Now, log 2 is b, okay, log 15 what to do? We can decompose this. Log of 3 into 5, that's the best what we can do, minus log of 2. This is again log AB. So it will be log A plus log B. So it will be log 3 plus log 5. If you get confused, go reverse. Log 3 plus log 5 will be log of 3 into 5. So we are correct. Minus log 2. This is nice. Now log 3 we know, A by 3. Log 2 we know, B. Problem is of log 5. How to tackle this? Now what can you decompose this? It will be log of 1 into 5. So what? Again you will come back to this situation. If you say log 2 plus log 3 is log 5, no, we are mistaken. Log 2 plus log 3, log 2 plus log 3 cannot be log 5. Log A plus log B is log of AB. So this will be log of 2 into 3. That will be log of 6. So log 2 plus log 3 cannot be log 5. And that option is ruled out. Now what to do? So here there is a special trick. So keep this trick in mind. It can be useful in some other situations also where this problem crops up. So anyway, log 3, so we will write it as A by 3. Okay, now log 5, we can write this as log of 10 by 2. log of 10 by 2. We are not changing the intrinsic value. 10 by 2 is 5. So it is log 5. Okay. Minus log 2. This will be now a by 3 plus. How to deal with this? This is log of a by b. Log of a by b. That will be log a minus log b. So this will be plus log 10 minus log 2. Isn't it? Minus log 2. This log 2 comes from here. So log 10 minus log 2 will be log of 10 by 2, that is this. This will be a by 3 plus log 10 minus log 2 minus log 2. A by 3, log of 10 will be 1 because log 10 to the base 10 is 1. Minus, so this is the way it helps us. So this becomes independent of all these. Log 2 we know how much? B. So minus b, again minus log 2. So again minus b, no harm. This will be a by 3 plus 1 minus 2b. Minus b is minus 2b. We can take LCM. LCM will be 3. So we will get a plus 3 minus 6b. Can we simplify this further? No. This is our answer. So log of 7.5 is a plus 3 minus 6b the whole divided by 3. This completes with your question 8. Question 9. If log x is a and log y is b, write down 10 raised to a minus 1. So 10 is the base, a minus 1 is the power. 10 raised to a minus 1 in terms of x. Okay. 10 raised to 2b in terms of y, and this part we will come to it later on. Okay, now see, log x is a, but here if you see there is no log involved. So that means that gives us an idea that we should try and get free of logs here. See, the previous sum is okay because logs were involved anywhere. But here when they say write 10 raised to a minus 1 in terms of x. So log is not involved anywhere. So what to do? But they have given log x is a and the base is what here? 10. So now we can try and get rid of logs. But that doesn't mean that you just remove off log. We have to convert it into equivalent exponential form. So can't I say 10 raised to a will be x? Okay. If the base was given here as 7, here also the base was given 7, no problem. Then it would be 7 raised to a is x. But here the base is not given, so we take it as 10. So it will be 10 raised to a is x. And then they gave you log y is equaling b. So the base is 10 here. So 10 raised to b is y. अभी इनको यहाँ पे कैसे भी करके यूज करना है. We have 10 raised to a minus 1. Power is a minus 1. The base is 10. So can't we write this as 10 raised to a into 10 raised to minus 1. See, before you do topic of logs, you should be fairly okay with indices, the basic sums at least. So 10 raised to a minus 1 will be 10 raised to a into 10 raised to minus 1. If bases are same, powers can be added. So a plus minus 1 is a minus 1. Reverse. You remember the law? A raised to m into a raised to n is a raised to m plus n. Conversely, a raised to m plus n will be a raised to m into a raised to n. So we are doing that. Now 10 raised to a. See, 10 raised to a is what? X. into 10 raised to minus 1. 10 raised to minus 1 is what? 1 upon 10 raised to 1, that is into 1 upon 10 only then. So this works out to be x upon 10, double underline this. So we have successfully put 10 raised to a minus 1 in terms of x. Now 10 raised to 2b. Okay, see, we have the value of 10 raised to b. So suitably manipulate this. This will be 10 raised to b raised to 2. Right? This will be 10 raised to 2b. So I have not changed the value, just written it in a different form. A raised to m, the whole raised to n is a raised to mn. Now 10 raised to b is what? Y. That is y square. So 10 raised to 2b has nicely come in terms of y. Now let us have a look at this subpart 3. Now log of p to the base 10, even if this was 10 was not given, it is understood the base is 10. This is given as 2a minus b. So what is given is log of p. P is not given. Log p is given as 2a minus b. Okay. Express p in terms of x and y. So now how do we extract p from this? We just can't say log go away. Okay, this is already given. So this implies 10 raised to 2a minus b, 10 raised to 2a minus b will equal p. Same logic what we are following for the previous, So base raised to index gives the answer. So log form converted into exponential form. So 10 raised to 2a minus b is equaling p, or p will be 10 raised to 2a minus b. Now this can be written as 10 raised to 2a into 10 raised to minus b. Now this can be written as 10 raised to a, the whole raised to 2. That will be same as 10 raised to 2a. Why we do this? Because 10 raised to a, the value we are having. You remember this 10 raised to a was x. We had written it down here, then I erased it. Into 10 raised to minus b. Okay. Now, but we have the value of 10 raised to b. I will again write it down here if you want. Log x is a. So the base is 10 here. So 10 raised to a will be x. And log y is b. Base is 10. So 10 raised to b will be y. Okay. Now what we do is, this is 10 raised to minus b, but so this was 10 raised to 2a. So we wrote this as 10 raised to a, the whole raised to 2. So that 10 raised to a can be used. And this will be 1 upon 10 raised to b as per laws of indices. Why we are doing this? Because we have the value of 10 raised to b, that is why. We don't have the value of 10 raised to minus b. Now 10 raised to a is how much? X. So this will be x square. 1 upon 10 raised to b. So 10 raised to b is y. So this nicely results in x square upon y. So we have now expressed p in terms of x and y. So this was a good question, and this completes with your question 9. Question 10. If log of 1 upon 27, if log of 1 upon 27, the full thing divided by log of 9 is equaling log y, find y. This is like a log division. So remember, log a minus log b will be log of a by b. It won't be log a upon log b. This is of the type log A upon log B. So that second law you can't apply. We have discussed this in great detail in the previous sums. So now how to go about it? Log of 1 upon 27 upon log of 9 is equaling log of y. This is given, fine. So we'll have to juggle with this. Now this we will write it as log of 1 by 3 cube. Nothing wrong. 1 by 3 cube will be 1 by 3 into 1 by 3 into 1 by 3, that is 1 by 27, and this is log. And this can be written as log 3 square. Log 3 the whole square nahi, log 3 square. This is equaling log y. That is important, you have to write because already given equal. Na? Now power becomes the coefficient, like log a raised to b. Law number 3. Log a raised to b is b log a. So this will become 3 log of 1 upon 3 divided by same log a raised to b, so b log a. This will be 2 log 3 is equaling log y. Anything can be cancelled here? No. But here I can see some scope. This is log of 1 by 3, this is 3. There is scope for further simplification. Now this you write it as 3 log 3 raised to minus 1. See, 3 raised to minus 1 is what? 1 by 3. And this is log of 1 by 3. So both are equivalent. Na? Only this 1 by 3 I have written as 3 raised to minus 1 upon 2 log 3. This will come as it is equaling log y. Now power becomes the coefficient. Log a raised to b is b log a. So minus 1 will get multiplied by 3. So this will become minus 3 log 3 upon 2 log 3 is equaling log y. Now see, this log 3 and this log 3, the term can get cancelled. So we are left with minus 3 by 2 is equaling log y, or log y is minus 3 by 2. Now sometimes they won't give log y here, they will just give it equal to y. Then our answer would be done, because then minus 3 by 2 would have turned out to be y and we had to find y only. But here they have given log y, so we will have to find y from log y. So answer doesn't end here because this is the answer for log y. Now the base is what here? 10. Base is not given, so it's 10. So it will be 10 raised to minus 3 by 2 is equaling y, or y is equaling 10 raised to minus 3 by 2. Now this power is negative, so it doesn't look good. So this will be 1 upon 10 raised to 3 by 2. Comfortable with this? So a raised to minus m will be 1 upon a raised to m, and we can leave the answer in this format. Okay, so this completes with your sum. Question number 10 over. Hope you enjoyed this topic. Thank you so much.